Light as a wave. It takes the form of a transverse wave, which means that while it propagates or travels horizontally, its individual points oscillate up and down, perpendicular to this horizontal axis. And this up and down oscillation of these points has a maximum vertical displacement known as the amplitude. As a transverse wave, this amplitude is perpendicular to the wave's direction of propagation. Importantly, when we've reached the amplitude at the top or the bottom, we're at a peak or a trough respectively. Another term we could use for the peak of a wave is crest. The slope of the wave at these extrema is zero or flat. It's also worth noting that the range of vertical displacement of a light wave is 2 times the amplitude. This is because in order to scale the vertical distance of the wave, we add the absolute value of each segment above and below the x-axis, and we get 2a as the total. Interestingly, from a chemistry perspective, there's really no definitive way of measuring or quantifying amplitude. I've seen distance, I've seen electric field strength per distance. Some textbooks don't even make acknowledgement of units for amplitude. Thus, we can see amplitude as more of a visual tool as opposed to a conceptual groundwork of or for a wave. All other factors constant, here's what it looks like to have waves of different amplitudes. Here's a high amplitude all the way to a low amplitude. Conceptually speaking then, amplitude and intensity, or brightness, are essentially interchangeable. So did you learn the following? Amplitude is the maximum vertical displacement of a light wave perpendicular to its axis of propagation. 2. The amplitude or negative amplitude heights are called the peak and trough respectively. At these extremes, the slope of the wave is flat or zero. 3rd, amplitude contributes to the intensity or brightness of the wave.